In this video, we're going to work our way through the planimetric method for determining average grain size according to ASTM E112. According to the planimetric method, the average grain size is determined by counting the number of grains within a known area in A. So the number of grains is then used to determine the ASTM grain size number, G. The precision of this method depends on how many grains are counted, and typically with a reasonable amount of effort, precision of about a quarter plus or minus of the ASTM grain size can be achieved. The results are shown to be free of bias and repeatable and reproducible to less than about plus or minus 0.5 of these ASTM grain size number G units. And to use the method accurately, you should mark off the grains as you count them. To determine the grain size using the planimetric method, start by selecting a magnification where you can see 50 to 100 grains in the field, the area that you're going to count. Then overlay a circle on that microstructure and calculate the area of that circle. And then you're going to start counting the grains in that area. All of the grains that are completely contained within that circle, we're going to recommend you use a blue pen to mark them off because they're going to be counted as inside. And then all of the grains that are intersected by the circumference of the circle, we're going to recommend using a red pen to mark them off, and those will be counted as intercepted. And then this number per area in A will be calculated using the number inside plus half of the number of grains intercepted, so N intercepted over 2, divided by the area of the circle. Now once you have your NA value, then you can find G using table 4 from ASTM E112, or you can calculate G more precisely in case your exact numbers are not in the table, using NA, using the equations provided in table 6 in the ASTM E112 to calculate G from NA. And I've provided a separate table of those calculations to the right. This is table 4 from ASTM E112, where you can use your NA value that you obtained here. Most likely you're using number of grains per millimeter squared, and you calculated something similar to one of these values in this column, and then use that to estimate the G value. For example, if you calculated 87.68 grains per millimeter squared, or somewhere in that vicinity, then what you have is an ASTM grain size number of about 3.5. Now some automated systems also use the planimetric method for a grain size estimation, and they're very interesting, and at some point in this program it would be wonderful for us to prove out some of those systems as we understand the method, understand how it works, understand the pitfalls, understand the potential pitfalls that can arise when this examination is performed using an automated system and we prove out an automated system. So now we're going to do a practical exercise using the planimetric method for grain size estimation. Answer the questions below to estimate the grain size for the microstructure in Exhibit 1 per the Jeffreys planimetric method. Here's our microstructure. It looks a little bit faint in terms of how clear the grain boundaries are, so we might want to make some improvements there. Let's improve the brightness and contrast to aid our counting. Now we have an improved microstructure to start our counting of grains for the planimetric method. Firstly, what is the printed scale bar length? 200 microns is printed on the previous image. However, if the printed scale bar is in mils, 1 mil is 1/1000th of an inch. So multiply the scale bar printed length in mils by 25.5 micrometers per mil to obtain the length in micrometers. Next, we need to measure the scale bar on the image. I measured the scale bar on my screen and it was 3.1 inches in length. So the measured scale bar length is 3.1 inches. Convert 3.1 inches to micrometers and you get 78,740 micrometers. Next, we need to measure the radius of the circle we're going to use. On my screen, the diameter was exactly 5 inches and the radius was 2.5 inches. It may not be so exact on your screen. So the radius of our circle is 2.5 inches. Now we need to figure out the area of the circle at 1x, meaning at the size of the actual microstructure. So the radius at 1x equals the radius times 1 over the magnification. That means that my 2.5 inch radius circle, I need to multiply that by the ratio of the length of the scale bar, that's the 200 microns, divided by the length on my screen of the scale bar, that's 3.1 inches. So 2.5 inches times the 200 divided by 3.1 means that the radius of my circle at 1x, the size in the microstructure, is 161 micrometers. So then I calculate the area at 1x, pi r squared, 3.14 times 161 micrometers squared, and I get 81,000 square micrometers, or about 0.0814 millimeters squared. Now we're at the point where we need to do the counting to solve the problem. So I started by ticking off all the grains that intersect my circle with the red pen. And then I ticked off all the grains that are wholly contained in the circle with the blue pen. Then I counted my red tick marks and I get that I have 52 intersecting grains. And I traced along the edge of the circle so that I made sure I didn't double count any marks. And then I counted to determine that I have 208 grains wholly contained inside my circle. And I traced along the tick marks so I didn't double count any. Now we need to calculate the number of grains per square millimeter at 1x, our N sub A, and that's the number of equivalent whole grains measured at the magnification used within the area. So the number of grains, again, going back to our formula, equals the number of grains inside wholly counted plus half of all the intercept grains. So N intercepted divided by 2. So that was 208 fully contained grains plus half of the 52 grains around the grain boundary. So that equals 234 grains. Then to calculate N sub A, the grains per square millimeter, we have that number of grains divided by the area of the circle, so that's 234 grains, divided by our 0.0814 millimeters squared, and we get N sub A equals 2,874 grains per millimeter squared. To estimate the ASTM grain size, we go to Table 4 in ASTM E112. We look for N sub A of 2874 in column 3, and we get the ASTM grain size from column 1, 8.6. And then to estimate the mean intercept for the grains. We look for our NA, again, same row in column 3, and then we look at column 9 to identify the mean intercept of 16.8 micrometers. Here's our closest value to the 2864 in column 3. So that would go to a grain size of 8.5 or a little bit higher, 8.6 in terms of ASTM grain size number in column 1. And then to identify the closest mean intercept, we look over here, column 9 for mean intercept, and the closest mean intercept we get is around 16.8, a hair lower, because our value was for grains per unit area was a little bit higher than the value in column 3.